Hello everyone, I'm Sangeeta, working as assistant professor in Dr. S.N.S. Radhalakshmi College of Arts and Science in the Department of Computer Science, Artificial Intelligence and Data Science. Here I am going to explain about expectations and maximization algorithm, commonly referred to as EM algorithm in the real world data science. Clean, complete data sets are luxury we are rarely get. Often, key variables are hidden, observed, or missing altogether. How do algorithm learn when they can't see the full picture? This is the exact problem we will solve today. So the problem space defined stage. Look at the magnifying glass on the left. In real world AI data set frequently having missing parameter or variables. Variables cannot observe directly. For example, if we have customer transaction data, we see what they bought, but their underlying intentions person is hidden. The solution space prototype stage. How do we solve this? We construct an iterative probabilistic engine that alternates between guessing the missing data and referring model parameter until the model stabilizes. A state we call convergence, unlockable capabilities. Here IEM breaks this deadlock through uh, two-step loop. Initialization start with the random guess for our model parameters. Each step expectations calculate the expected log likelihood and given our current parameter guess. M step maximization find the new parameter that maximize this expected log likelihood and repeat until changes in the parameter is giving the correct answer. And then here look at the grid left. Imagine a data table where several entries marked up question marks are completely unknown or missing. Why can't we just use standard maximization likelihood estimations or standard regressions here? Because MLE requires complete data to complete exact probabilities. When values are missing, taking deviations to find peak likelihood yield intractable equations that cannot be solved analytically. EM provides an efficient probabilistic workaround. This diagram shows what I like to call the EM iterations engine. Think of it as a continuous feedback loop. Let us walk through the engine step by step. Step 1, initialization. We begin by picking initial values of our parameter, example mean, variance, and cluster weights. Step 1, expectations. Each step we evaluate the responsibilities of expected values of the hidden variables using our current parameter estimates. We ask, given what we currently believe about the parameters. So second one is maximization step. Third one is convergence check. So maximization estimation mechanism calculate the conditional probabilities um, using calculator expectations without the changing model parameters. The graph with the arrow on the right shows jump step climbing up the peak to optimize the parameters. No algorithm is perfect, and as a AI engineers, you must know when to use EM and when to beware its traps. Here, Ghost strengthens elegantly handles missing or incomplete data, guaranteed convergence to local maximization, provides probabilities cluster, and EM can get a struck local optimum, instead of finding the global optimum. So EM actually used in industry, e-commerce and retail. Suppose Amazon has millions of unlabeled customers transactions. They want to group shopper into segments, example bargain hunters and impulse buyers, premium shoppers. EM starts with unlabeled data, estimates the membership probabilities, update the buyers group parameter, and deliver clear customer segments for targeted marketings. Thank you.